In my research, I've done things that do not always please people in the community. We are basically working in the same field, and I've been very, very lucky because you did these things earlier. What could you tell about that? How was it? Was it hard?
It's very hard. You study physics and you do problems, and then you look in the back of the book and you confirm that you got the right answer, and that gives you a good feeling. And then you go do research and you look to your other colleagues and maybe you get a different answer than they get and suddenly feel like you did something wrong. The nice thing about science is we publish our results. We sort of say, if you do this experiment, this is the result you get. Whether you like it or you don't like it, that is the result that we get. You're free to look through our data or our process and tell us if we've done something wrong. But until then, here are the results.
But if I recall correctly, so we are measuring the Hubble constant. From the 60s to the 90s, there has been a huge conundrum about that. And then in 2011, so you get your Nobel Prize. So you have now a voice super important in the community, and you start saying that you find something again that is not compatible about the Hubble constant. Don't you think that we are missing surprises by focusing too much on certain kind of science? We have seen that the universe is accelerating instead of decelerating. This tells us that we might be wrong on many things.
There's a statement about models, that all models are wrong, but some are useful. That dark matter, I'm not sure exists, or dark energy, I'm not sure that it exists, but right now it's the benchmark because it's the closest to matching most of the data. Anybody who hasn't studied the history of science is crazy because these things repeat, and so there's been epicycles and there's been ethers. The universe is complex, filled with dark things that we don't understand, dark energy, dark matter, and so be open to surprises.